Yeah, hello everyone. Today I will be discussing about linear transformation. So, what is a linear transformation? We know that if U and W there are two vector spaces, and if T is a function from U to W, if T is a function defined from U to W, then this T is known as linear transformation. If T of x plus ky, this must be equal to what? T of x plus k times T of y, where x and y we are choosing the vectors from U, and this k is scalar and k we are choosing from field F, where U and W, these two are the vector spaces over some field F. So example, as it is clear from the name linear transformation. So this, suppose if I am choosing T of x equal to x, so obviously this is what? Linear transformation, because this, if I am if I will replace by x plus ky, so this will be what? X plus ky, and this equal to what? T of x plus k times T of y, because T of x is x and k times T of y, so this is a linear transformation. So second example we can see T of x, if you are having T of x equal to x square, is this a linear transformation? No, because if you will replace x by x plus ky, so this will be what? X plus ky whole square, and this is not equal to x square plus k square and y square, because we will get here 2x ky, so that is extra term, so this is not a linear transformation. And also there is one property: if T is a linear transformation, then T0, image of 0 will be always 0. If T is a linear transformation, then always image of 0 we can get 0. But what about converse of this part? If T0 equal to 0, then what we can say, whether the given linear transformation is linear or not linear? If T is a linear transformation, then always T0 0. But if T0 0, then what we can say? Then this is not mandatory that if any functions are satisfying this condition, so that will be linear transformation. Simple example, we can see T of x equal to x square. So here T of 0 is what? T of 0 is 0. But because this is a quadratic we are getting, so this is not a linear transformation. Yeah, let me explain next problem. Suppose if you have given some general problem, T is a linear transformation from R square to R square, and T of xy, this is given as x minus y, first component x minus y, and second component is what? 2x. So what we can say about whether this T is a linear transformation or not linear transformation? So in this case, if I am choosing here two vectors of R square x1 y1, so what will be T of x1 y1? This will be what? So this equal to x1 minus y1 comma 2x1. So what will be T of x2 y2? T of x2 y2 will be what? This will be x2 minus y2 comma 2x2. So what will be this one? If I am adding, if I am asking T of x1 comma y1 plus k times T of k times T of x2 comma y2, this will be what? This we can write, because T of x1 y1, x1 minus y1, so we can write, so T of x1 y1, this will be what? X1 minus y1 comma 2x1 plus k times, and T of x2 y2 is what? x2 minus y2 comma 2x2. This you can consider equation first, So now what will be this one? T of, if I am asking, because if you want to prove that this T is linear transformation, then what we have to prove? T of x1 plus kx2, comma y1 plus ky2. This must be equal to what? T of x1 y1 plus k times T of x2 y2. So what will be this expression? T of x1. So here first component is x1 plus k x2 and second component is y1 plus k y2. So here T is defined linear transformation is x minus y and 2x. So first component minus second component, then what you will get? X1 plus kx2 minus y1 minus ky2, comma 2x means two first component. So we can write here 2 of x1 plus kx2. So what will be this expression? This again we can work out. This we can solve further. Then what we will get? Yeah. So this we can give equation 2. So now if I will compare first and second, so T of x1 plus kx2 comma y1 plus ky2, this must be equal to T of x1 y1 plus k times T of x2 y2. So what we can say, right hand side part of this first equation is x1 minus y1. So if from the equation first, if you will add these two number, then what you will get? I hope you are aware component wise addition. If you want to add x1 comma x2 plus y1 comma y2, then how we can add? So this is called component wise addition. So this will be x1 plus y1 and x2 plus y2. So this will be what? Equation first. We can write right hand side of equation first, x1 minus y1. So we can write here x1 minus y1 plus k times x2 minus kx2 minus ky2, comma second component. So we can write 2 times x1 plus x2. So this will be what? This we can write this equal to, we can write x1 plus kx2 minus y1 x1 plus kx2 minus y1 minus ky2 and comma 2 x1 plus kx2. So right hand side of equation 1 and 2 we can make equal. So this will imply T is a linear transformation. So if we have to prove that T is a linear transformation, so this T x1 plus k x2 comma y1 plus k y2 we can make equal, this equal to T of x1 y1 plus k times T of x2 y2. So now next topic is I am going to discuss what is image and what is kernel of a linear transformation. So we know that we have studied what is image. Image means what? Image. This image is also known as range of T or image of linear transformation, and kernel is defined as if we are having T the linear transformation from U to W. So kernel is defined as set of all the elements of the domain stage which is having image 0. So kernel of a linear transformation is defined as set of all the collection domain which is having T image 0, and image of a linear transformation is defined collection of all the outputs. If I will explain by Venn diagram, suppose this is what set A and this is what set B. Suppose in A is x1, y1 and x2, and here suppose if I am writing k1, k2 and k3, and here x1 is mapped to k1, y1 is mapped to k2 and x2 is mapped to k3. So what will be output of this? What will be range of this function? And here suppose f is defined from A to B. So range of the function is what? Collection of all the outputs k1, k2, k3. And this kernel is defined as set of all the elements of U which is having 0. So obviously we can say this will be what? Subset of V, and this image set this will be subset of W. But how you will solve if you are having some linear transformation, then how you can calculate this kernel of linear transformation and image of linear transformation. So next problem is given. T is a linear transformation defined from R4 to R3. Sorry. So we have to calculate kernel of this linear transformation. So how we can calculate? So kernel means what? We have to put image 0 if I am choosing any vector. If you can choose x, y, z, and t, any vector of R cube. So according to kernel R power 4, so if I will apply here t x y, if I will apply t here in the given vector, so t of x y z and t, so this will be what? 0. Here we can write if I am choosing one random vector from kernel t, so what will be according to kernel of linear transformation, this I am choosing one random vector of from kernel t. So if we are claiming that any vector is belonging in kernel T, so it means if I will apply linear transformation on that, so this will be what? T of x, y, z, t, this will be what? 0. And T of x, y, z is defined as here x plus y plus z plus t, x plus 2z minus t, x plus y plus 3z minus t. So this will imply now all the outputs we can put 0. So first equation x plus y plus z plus t, this equal to 0. This we can assume equation first. Similarly, second equation x plus 2z. Second equation we can write x plus 2z minus t equal to 0. This is second equation. And third equation x plus y plus 3z minus 3t equal to 0. This is what equation third. So now we have to solve, and the value of solution of this system of linear equation, this will be was kernel of T. Now how to solve this system of linear equation? There is easy way we can convert this system of linear equation in the matrix form. So this will be what? 1, 1, 1 and 1, 1, 2 minus x, y, z, t. So here y is 0. So here y is 0. This x, y is 0. And here x, y 0, z is 2, and t coefficient minus 1. And here we can get 1, 1, 3, and minus 3. So this matrix we can convert into row echelon form so that our calculation can be reduced. Because here you can apply substitution method also. First you calculate x in terms of zt, then you put in other values. Otherwise, we can apply row echelon form to reduce our calculation. So you can apply row echelon form here. So this we can apply. Just one correction here. Y is given here plus minus y, not plus y. X minus y. So this element will be what? Minus 1. So now how you can convert into row echelon form? This, so we can apply R2 is replaced by R1 minus R2, and R3 is replaced by R1 minus R3. So what we can get? 1 minus 1, 1 and 1. Now 1 minus 1, R1 minus R2, 0, minus 1, 1 minus 2, minus 1, 1 plus 1, 2, 1 minus 1, 0, minus 1, minus 1, minus 2, and 1 minus 3, minus 2, 1 minus 3. So you will get 4. So if you will see here, this minus 1, minus 1, 2, and this minus 2, minus 2, 4. So by applying row operation, we can make this third row 0. And this second row we can replace by minus 1. So what we can get? 1, minus 1, 1 and 1. 0. Now second row I have replaced by minus R2. So 1, 1 and 2, and third row will be what? Completely 0, 0 and 0. So final we are getting row echelon form. Now again from the given matrix we can convert in system of linear equation. So how you will convert into system of linear equation? So 1 minus 1, so we can write x minus y plus z plus t equal to 0. This is our first equation. Second equation what we can write? X is 0, so z plus x, y, z. So we can write y plus z plus t. Second equation we can write y plus z plus 2t is equal to 0. And third equation we can get what? 0 equal to 0, because we are not going to get anything. So we are getting two system of linear equation. If I will add these two equations, so you are looking here minus y and plus y, this will be what? This will be cancel out, and z plus z, 2z. So we can get 2z plus 2t is equal to what? X. So x value we are getting 2z plus 2t. So now what will be y value? So y we can write y equal to x plus z plus t, and x we are getting 2z plus 2t. So what will be y? Y equal to x value is 2z plus 2t, and here z plus t. So final y will be what? 2z plus z, 3z plus 3t. So x we are getting 2z plus 2t, and y we are getting 3z plus 3t. So now what will be the solution of the given system of linear equation? We can write here x, y, z and t. So what is value of x? X value we are getting here 2z plus 2t, 2z plus 2t. Y value we are getting 3z plus 3t. Z is z and t is t. So now z and t we can separate. So what will be z and what will be t? Simply we can separate. So if you will separate z, so what you can write in the bracket? 2 and 3, and here 1 and 0 plus t. So t what you can write? 2, and here we can write 3 and 0 and 1. So what will be basis for kernel T? We can write basis for kernel T. Basis for kernel T equal to what? These two vectors we can write 2, 3, 1, 0. And second vector we can write 2, 3, 0, 1. So what will be dimension of this kernel? Number of elements in the basis is known as dimension. So we can write here 2310 and 2301. These two are the basis for kernel T, and dimension is what? 2. So if you are having any given linear transformation, you have to calculate kernel of T. So directly that image set you can equate 0, and after that you can solve the system of linear equation. Sometimes we can solve it easily by substitution method, and sometimes you can apply row echelon form, and we can get relation between x, y, z, t, and so this will be basis for kernel T, and dimension, number of elements in the basis, is known as dimension. So dimension of kernel T will be 2, and basis is 2310 and 2301. Next problem is given. T is a linear transformation from R cube to R cube. T of x, y, z is given x plus 2y minus z, y plus z, and x plus y minus 2z. So how you will find basis for image T? So basically what we have to calculate, we have to calculate what is image of this linear transformation. But how you will calculate image of this linear transformation, because we don't have any input. Because how you will calculate image of a linear transformation? If some inputs are given to you, then you can calculate image of linear transformation. So here you are looking, T is a linear transformation from R cube to R cube, and we know that standard basis of R cube is what? Standard basis for R cube is what? Standard basis of R cube is what? 1, 1, 0, 0, 0, 1, 0, and third is what? 0, 0, 1. So these three are the standard basis of R cube. So now we are going to calculate image of these three bases. If nothing is given to us, then we can apply standard basis. So what will be image of T100? So now we have to calculate image of these three elements through the given linear transformation. So this equal to T of 100 will be what? 100. So here x component is 1, y component is 0, and z component is also 0. So we can get 1 first component, second component 0, and third component 1. Similarly, T of 0, 1, 0, 0, 1, 0, this will be what? Now y component is 1 and x component and z component 0. So we can get 2, 1, and here 1. Similarly, what will be T of 0, 0, and 1? So this will be what? X component 0, y component 0, and z component 1. So we can get -1 and 1 and -2. So now these outputs we can write down in the matrix form. So first row 1, 0, 1, second row 2, 1, 1, -1, 1, and -2. So now again this output we have to convert into row echelon form. Why? Because image of linear transformation also we have to calculate linearly independent. So why we are converting in row echelon form? Because the obtained outputs, it might be linearly dependent. So we can apply row echelon form so that we can get linearly independent vector in the basis for image T. So you are looking here pivot element 1. So this element we have to make 0 and this element we have to make 0. So this we can write 1, 0, 1. And now you can apply row operation also. You can apply here R2 replaced by 2R1 minus R2, and R3 we can replace by R1 plus R3. So 1, 0, 1, and 2 minus 2, 0, and 0 into 2, 2. So 2 minus 1 you will get 2 minus 1, 1, 1 plus 1, 0, 1 plus 0, 1, and 1 minus 2, minus 1. So again, we can replace R2, this R3 we can replace by R1 plus R2. So this we can get 1, 0, and 1, 0. If you want, you can replace by R2 by -1 also. So 0, 1, -1. And third row will become 0, 0, 0. So what will be basis? What will be basis for range T? So basis for range T we can write. So basis for range T. Basis for range. This will be what? Always you remember, only we have to take number of non-zero row. We have to choose if any row is 0, 0, complete 0. So we cannot choose that. So basis for range T is 1, 0, 1. And second non-zero row is 0, 1, -1. And how you will calculate dimension of range? So dimension, because number of vectors is known as dimension. So this is what dimension of range is here 2. So this is the way to calculate image and kernel of linear transformation. In kernel of linear transformation, the given image you can equate 0. And for calculating image of a linear transformation, directly we can take image of this standard basis. But sometimes it may be given to you some different basis. Suppose if they have given some different basis like this T is a linear transformation from some vector space to some other vector space, and domain set is spanned by some other vectors. So in that case, we have to apply image of the given basis vector. So in that case, you no need to consider this standard basis. If they will give you some other basis like 1, 1, 2, 1, 0, 1, 2, 0, 3, if they have given different, so we have to calculate image of the given basis through the linear transformation. In that case, this standard basis cannot be considered. So this you keep in mind, and number of elements, if you are asked to calculate dimension, so you can calculate number of elements in the basis are known as dimension. So next topic is invertible linear transformation. When you can say a given linear transformation is invertible linear transformation. So when we can say that linear transformation is invertible if T is a linear transformation from U to W. This said to be invertible transformation if and only if kernel of T equal to 0. If in kernel of linear transformation only we are getting 0 vector, so that linear transformation is known as a invertible. So let me explain one problem based on this invertible. So let us assume that this one linear transformation is given T of x, y, z. And also we know that if a linear transformation is invertible, then we can calculate inverse of linear transformation also. So T of x, y, z, this is given 2x, first component, second component 4x minus y, and third component is given 2x plus 3y minus z. So as I explained, kernel T means what? The given image you have to put 0. So for kernel T, this will imply T of x, y, z. This must be equal to what? 0. So this given vector 2x, first component, second component 4x minus y, and third component 2x plus 3y minus z. This we can equate what? 0, 0, 0. So what will be first component? 2x equal to 0. So this will imply x equal to 0, and y is also 0, and z is also 0. So x is 0, y is 0, and z 0. So what we are getting? Kernel. So kernel of linear transformation. In kernel of linear transformation only we are getting 0, 0, 0. So kernel T is what? 0 vector. So we can say that this linear transformation is what? Invertible. Now how you will calculate inverse of a linear transformation? So better we can let us assume that T inverse of A comma B and C, this equal to what? X, Y, Z. So now I am going to calculate inverse of a linear transformation. So this will imply A, B, C. This equal to what? This equal to T of x, y, and z. So here I have assumed that inverse of this linear transformation T of x, y, z is what? A, B, C. So now what we can write? A comma B comma C. This we can write this equal to. Now what is given linear transformation T of x, y, z? This is given 2x, 4x minus y, and 2x plus 3y minus z. So now you can compare. So what will be first component? X equal to what? 2x equal to a. So x equal to a by 2. So this will imply a value is what? A value we can calculate. A value is nothing but what? 2x. So a value is 2x. And similarly, what will be y value? So 4x minus y is given. So here x value we are getting a by 2. What will be y? So 4x minus y. This equal to 4x minus second component 4x minus y equal to b, and so y will be what? Y equal to 4x, and x is what? A by 2. So 4 into a by 2 minus b. So this equal to what? Y value will be 2a minus b. Similarly, z you can calculate. So z will be what? Similarly, z third component you can calculate. This is nothing but 7a minus 3y, or minus plus or minus 3y and minus z. So this will be what? Value of here 7a plus 3b minus c. So what will be T inverse ABC? So T inverse ABC will be what? T inverse ABC. This equal to we have in beginning we have considered T inverse ABC equal to XYZ. So what is value of x? X value is a by 2, y value 2a minus b, z value 7a plus 3b minus c. So this also, if you want, you can convert T inverse. A, B, C you can replace by x, y, z. So T inverse of x, y, z will be what? X by 2, comma 2x minus y and 7x plus 3y minus z. So this we can write. This we can write 7x plus 3y minus z. So this will be what? Inverse of linear transformation. But you remember, if kernel T is non-zero, if you are getting kernel T, because in this case we are getting kernel 0, if kernel T is not equal to 0, then this linear transformation is not invertible and we no need to calculate inverse of linear transformation. So if you are asked to calculate inverse of linear transformation, this it means kernel T has to be 0. So in next video, I will be discussing about matrix of linear transformation and how to calculate change of basis matrix and similar matrices. So thanks for watching.